You could try doing this by yourself, by the way, if you hadn't done that already. It's not too hard to do. You just got to get dx dt and dy dt, and then apply this formula right here. That's it. That's all there is to it. I'm only going to do one more example. So let's see. To do this derivative, I think the easiest thing to do is pull that 1/12 out of there, and then say I'm going to go times, so it'll be power rule 3/2 times 8t plus 8 to the 1/2. All right, so we can simplify that a little bit, reduce these, and we got 1/8 times 8t plus 8 to the 1/2 power. And then our dy dx is just 2t plus 1. So because this one's a little bit weird, it's got the square root in it, I thought it'd be easiest, since we got to put dx dt squared into the formula, let's go ahead and find out what dx dt squared is. And that way, we do that as a separate step, and then we can plug right into the formula. So what I'm going to get is I'm going to square this and have 1/64. I'm going to square this, and the square root's going to cancel, and I'll just have 8t plus 8. So then that can simplify as 1/8 times t plus 1, right? Or just t plus 1 over 8. So then, since we're going to do that, let's just go ahead and put the dy dt as 2t plus 1 squared. I'm not going to do anything with it. I just want to show that I've found the squares of both the derivatives. And then I can just plug right into the arc length. The arc length is going to be the integral from 0 to 2 of the square root of my dx dt squared, which I've already worked out, and I'll write it now as t plus 1 over 8, plus my dy dt squared, which is 2t plus 1 squared. I'm not even going to bother to square that out and find out what it is. I'm just going to put it right into my calculator like that and get 6.087 equals approximately 6.087. And that's it. All right, so that is finding lengths of parametric curves. Now, what if you didn't have a parametric curve, right? So what if you had just let's go back to our favorite function that we started out integrals with, y equals x squared on the interval 0 to 2, right? So we know that looks like a parabola here, 0 to 2. So this is 2, and this is 4. Right? So I wonder how long that is from x equals 0 to x equals 2. Right? So this is no longer t, this is x. All right? So here's what you can do. You can always take any function and parametrize it. Parametrize it. Make it parametric. All right? By doing this. We just say x equals t and y is equal to t squared. Right? Because y equals x squared. So you just say x equals t and y equals whatever that function is. But we're going to have a way to simplify that. Then you can see that your dx dt is just going to be 1. That will always happen because of the way we're doing this, so that helps us simplify the work. And then dy dt is 2t. Right? Then you can go back to s is the integral from a to b of dx dt squared plus dy dt squared, so that's, we have the square root of 1 squared plus 2t squared dt. All right, so things you want to notice is no matter what my function is, what I have here is always going to be 1, right? Because I'm always going to say x equals t and get dx dt equals 1. And whatever I have here is always going to be f of x, right? Where f of x is my function that I started with. All right, f prime of x, actually. F prime of x, the derivative. All right, so, that's the hint of how we're going to set this up. So this is equal to the integral from 0 to 2 of square root 1 plus 4t squared dt. There are ways to do this using a trigonometric substitution. We're not doing that in this course, so we just throw it in the calculator. I did that already. I got 4.647 for that integral. All right, so basically there's this. Since you're always going to get 1 here and you're always going to get f prime here, for y equals f of x on x from a to b, all right, the arc length of the curve, s, is going to be equal to the integral from a to b of the square root of 1 plus f prime of x, or you could say dy dx, squared dx. So it's dx now, not dt, right? Up here I made it dt because we forced this to be a parametric, but what I'm saying is you don't have to force it to be a parametric. Okay, and so next we'll do an example of that, and then we'll talk about the homework.